Scientists, researchers, and some big companies are eager to jumpstart the next generation of computing, one that will be far more sophisticated and dependent on understanding the subatomic nature of the universe. But it's a huge challenge to take this new quantum leap forward. Science correspondent Miles O'Brien has more.
Okay.
It's a chandelier that may soon shed light on the true nature of nature. A quantum computer designed to understand the rules of the physical world, to find new ways to cure diseases, stop pandemics, develop renewable energy, and tackle the climate emergency.
If we want to understand nature, since nature obeys quantum mechanics, let's build a machine, let's build technology that works like nature.
Dario Gil is a senior vice president and the director of IBM Research in Yorktown Heights, New York. Computers today operate in the binary language of ones and zeros. Fast and capable, sure, but they are, after all, digital totems of reality.
So no matter how hard we try, the best we can do is to approximate the complexity of our world. And quantum machines are the first technology that we've created that allows us to, by mimicking that behavior of the natural world of quantum physics, to be able to simulate it, to understand it better.
These intricate machines are designed to do just that. At the bottom are simulated atomic particles called qubits, which act in mysterious, non-intuitive ways. The manner in which they spin and interact can greatly increase the capability and efficiency of computers. Besides being a potential game changer for solving problems in the natural world, quantum computers may lead to greater optimization in manufacturing, logistics, transportation, and finance. And they have the potential to challenge and revolutionize encryption.
I believe we are at the birth of a revolution in technology, a different way of thinking about information.
Quantum physicist David Aushallam is a professor at the Pritzker School of Molecular Engineering and Physics at the University of Chicago.
Well, I think our classical view of the world and classical modeling of the world has worked very well, and it's helped us quite a bit, and it continues to help us. But some of us think about this moving a little bit from a world of black and white into color.
He gave me a tour of his quantum measurement laboratory. What is the goal of this lab anyway? What are you up to here?
Yeah, so here we're developing new experimental techniques to be able to look at individual electrons and atoms and see how they convey quantum information.
They combine fast pulses of light and microwaves to experiment with individual atoms and electrons.
And measure their properties as a way to investigate them, atom and electron by atom.
So you're able to manipulate at the atomic level.
Correct.
You're controlling atoms.
With microwaves, and we probe them with pulses of light.
But controlling atoms is no small feat. It turns out qubits are very delicate, creating a big engineering challenge in designing quantum computers.
So we are in the Google Quantum AI lab, and we are surrounded by a fleet of quantum computers.
Physicist Eric Lucero is a lead engineer for Google's quantum computing enterprise based in Santa Barbara, California.
Each one of these we're testing something slightly different.
Quantum computers look like a Rube Goldberg espresso maker in order to keep their finicky qubits happy. For them to remain able to compute problems, they cannot be disturbed by the slightest bit of noise, electromagnetic or thermal.
We want to make sure that the thermal noise is well below our quantum signal. Okay, so we make our systems out of superconducting electronics.
Which means they have to be kept cold, extremely cold. Everywhere we went, the computers had to be chilled to almost absolute zero, or about 460 degrees below 0 Fahrenheit. Simply sending commands to and receiving responses from qubits without disturbing them is a Herculean task.
We're learning about information that it's so much more delicate in the ways that we have to interact with it. When we go and actually interact with these systems, we can alter it.
As a result, the quantum computers that exist today are riddled with errors. Researchers deal with this through statistical analysis and sophisticated error correction techniques. But achieving a fully error-corrected quantum computer is their goal.
The summit for us is to build a fault-tolerant, error-corrected quantum computer.
The race is on to be first, and China appears to be the leader. Its announced investment in quantum computing is more than $15 billion. IBM and Google don't share the amount they are spending internally on quantum computing research and development. But in May of 2023, the companies announced a $150 million gift to the universities of Chicago and Tokyo to try and keep pace with the Chinese.
You're probably standing between two of the biggest quantum computers in the world.
So if I stay here long enough, I'll get smarter?
Possibly.
Back in Yorktown Heights, I met IBM's VP of Quantum, Jay Gambetta. The company is already rolling out quantum computers that are not perfect, but are built with some error correction.
If we can increase the rate at which we can scale whilst continuing to make improvements on the performance, we'll be in a point where these will be able to do something we could never do with classical computing.
The company has already deployed more than 75 quantum computers. Mostly, users are trying to find ways to program these machines. It's entirely different than classical computer coding.
It is definitely going to be a huge competition. I think this needs to be the decade where quantum computing emerges as a technology that will be a permanent part of the landscape of the world of computing. But a race also has a connotation that like you run something and it ends. I don't see this as ending.
Researchers say a practical, error-free quantum computer may be a decade away. But the goal of solving huge problems with the smallest particles in the universe is alluring enough to quicken their work. For the PBS NewsHour, I'm Miles O'Brien in Yorktown Heights, New York.